Okay guys, time to have a look at the 2023 Junior Cycle Engineering exam. So 2023. So you had to answer every question. They don't have equal marks. You can write in pen or pencil or whatever. So yeah, let's get started. So the first one there says a dash cam is used in the car shown opposite. So the advantage of using a dash cam, well, a few. Okay, so one thing is cheaper insurance. That's one thing. And also if you have an accident. It will help you when a claim maybe. So you're better off to put down 2 anyway, I think, just to be sure. So disadvantages of using a dash cam then. One is it blocks your view maybe. And it might be a distraction. And also maybe if you cause an accident. So again, just better to try on a couple of things there. So that is the first question 1A. So B there, select one of the drinking straws shown and explain how its use may impact negatively on the environment. So select one of them. So I would say the paper drinking straw there. So the selection would be paper. And the negative impact is they're used once and thrown away. So that causes litter. It's wasteful. Now plastic is worse, admittedly, but I mean ideally it would be better if we didn't use straws, I think. And it can be eaten by animals. So stuff like that. Now the stainless steel drinking straw, it uses a lot of energy to create it, but at least it's reusable. But the other thing then is they can have bacteria inside in them if you don't clean them properly. So that's just if you had chosen the stainless steel one, but at least the stainless steel one it's not thrown away after one use. Now B part 2 there then says state 2 properties of stainless steel. Oh, so it's shiny, strong. No, I'm putting in a couple here. Doesn't rust easily. And it's good for hygiene. So that's a couple there anyway. Okay, so page 4 here then, which is it's still question 1. So the first one there said a compression spring is used in the 2023 Junior Cycle Engineering project. Now, the people that made this project were well familiar with this, so don't worry if this is unfamiliar to you, because there will be a question, I presume, from the project of your year, whatever year you are doing your project or doing your junior cycle. But anyway, so the meaning of the compression, so explain the meaning of the term compression. So compression is two forces pushing against each other. Okay, like in the voice, so compression, if we just kind of give a little sketch there of a force coming in and another force coming in, and if you just want to draw the spring, a simple diagram like that, or an object or whatever. So two forces pushing against each other like that is compression. Identify one other application of a compression spring. Well, they could be used in a biro or a pen, or they can be used in car wheel suspensions. Then onwards there to part 3 there, so it says describe the function of the separator mechanism there. Now that's what's called a Y separator there, and every time the ball, it swivels over and back when a ball rolls down there. So the function, or they wanted the function of the separator, so it was to direct every second ball left and right along different paths. Along different pathways. So when the marble would fall down on the left there, it would roll this way, and then the separator would send the next one to the right. So that is page 4. Okay, so page 5 there, then they're asking about drones have an increasingly important role in smart farming. So state 2 applications for a drone in farming. Well, lots really, but they can be used for monitoring sheep or cattle in, let's say, hills or mountains. And they can also be used for spraying crops. And I'll add a third one here, is checking if crops are ready to harvest. So yeah, they have lots of uses in the future there for farming. So then there, explain why 3D printing is suitable for the manufacture of drone parts. Well, a lot of drone parts are made from plastic. So I'm just going to say a lot of parts are plastic because they are light. And one great thing about making stuff, they're often 3D printed. So there's almost no waste. And you can use, I'll just say, lots of colors. So just to go back over that there, so the fulcrum is kind of the point that it swings around or hinges around or whatever, because the load is the weight that you're pulling up and the effort is the force it takes to pull it up. So fulcrum was the answer there. Then on to E part 2, so it just says explain why a pulley wheel is used in the gym machine shown. Well, a pulley wheel reduces friction. Because the wheel turns with the rope rather than just the rope sliding over it, the wheel spins with it. So there's reduced friction and reduced wear and low noise, unless it was squeaking and you might need a drop of oil. But so yeah, like I said, always throw in a couple. I think you're safer than just putting in one, you know, just in case. Then 2 lathe processes used in the manufacture of the dumbbell. So you can see here, I don't know if it's coming out on the video there, but you can see here the crisscross there from the knurling for grip. And the second one there, well, again, there's an angle on this here which is taper turning. And almost certainly at the ends there's facing off. So that would be 3 there, just again to be safe. Okay, next up then is page 6. So engineering and product design are central to the production of custom-made bespoke furniture. So custom-made is kind of one-off or novelty stuff. It's not mass-produced. It's like the novelty lamp shown over here. So it's got an adjustable body. Outline one reason for this design feature. Well, the good thing about an adjustable body, kind of like, you know, what you'd see there on document cameras in school and stuff there, is that you can adjust the angle to change the light. Or just another reason there is you can change to new pool positions. So next up there, then it just says to name the type of nut shown and explain why it's suitable for the novelty lamp there. Well, that's a wing nut or a butterfly nut. It's called, okay, or a wing nut. Now you'd see them in engineering on the hacksaws, older hacksaws anyway, and the reason for them is that you don't need any tools to open or close them. Just your thumb or finger. Okay, so that's why they have the things sticking out there, just so you can do it by hand. Alright, so B here, then the next up there, it just says the body parts are shown are made from acrylic. Calculate in millimeters the overall length and the overall width. Okay, so from the bottom here, it's 10 from the bottom to here, and 80 plus 10 is 90, and then it's 15 there, which is 105. So 10 plus 80 plus 15 is equal to 105. And always double check that. And the width then, so the widest part of it up here is 15 and 15, because from the center to here is 15, so the radius is 15, so the diameter is 30. So again, radius 15 by 2 equals 30. The reason I'm writing it down like that is just if you made a mistake, but they could see, you know, that you had the right idea, you could still get marks for it. So, you know, so I'm saying 15 plus 15. So it's just slightly safer to do it that way. And the next part here then, it says, describe how the profile of the body may be marked out accurately. Now you can kind of presume here that you would be getting a rectangular piece to mark that out on. So just draw a rectangular piece here. So the first thing you would be doing would be putting on a center line. So I'm just going to do this in point format. So I'll say put on center line. Would be the first thing that I would do. Then I would measure up 10 from the bottom. $10 mm. Step 3 then is I would measure up 80 more, which is 80 millimeters more, and dot punch both. So that would give you the 2 dot punches. Step 4 then would be draw arcs radius 10 and radius 15 on top. So that's going to give you an arc of radius 10 down here and an arc of radius 15 up here. And the next step there then, step 5, would be to draw tangent lines. So a tangent line just touches the outside of the circle like that and like this. Draw tangent lines to the arcs. And then finally 6 would be oh yeah, so you wouldn't be dot punching if it's on acrylic, so that's it, yeah, that would be it. So describe how the profile may be accurately marked out. So there we go, that's page 6. Okay guys, so page 7. Identify 2 safety precautions to be taken when drilling the acrylic body parts. So anything to do with drilling, wear safety glasses. No loose clothes or jewelry. And another one there is make sure that the piece is held securely. In the vise, and set the drill at the correct revs per minute, RPMs / speed. And having timber underneath it and all that. There's loads of them, but they look for 2 there. So that's 4 anyway. Just again, always be safe. Next up there then is explain why the table and the base of the drilling machine are made from cast iron. Okay, so cast iron is very strong, heavy. Now you want the base to be heavy so it's good and secure and solid. Doesn't wear easily. and it gives good castability, which means that when it's poured it's very watery and it'll take the shape that you want very easily because it's watery. So again, all of those are good. Next up there then, it says circle the correct alloy combination for cast iron. So copper and zinc, no, definitely not copper and zinc. Iron and chromium, no, that's stainless. So iron and carbon would be the circle. Now it said circle, so iron and carbon. No, that's always complicated because iron and carbon is steel. Up to say about 2%. So 2% carbon. But then say if you go, it's called cast iron then. If you put in like 3 to 5% carbon. So that confuses a lot of people. So it's called steel up to 2% carbon, and then it's called cast iron kind of when it's up around 3 to 5% carbon. Next question there then is to match the safety signs shown here by just drawing lines to them. So prohibited, a hazard, and a safety condition sign. So prohibited anyway is this one. So prohibited is something you are not allowed to do it. And this is a hazard or a warning sign. Okay, so that's kind of just bringing some danger to your notice. And finally there then the safety condition sign is the fire exit sign. So there we go with that. So that is page 7. Okay, so page 8 here, it's the novelty table lamp often falls over when in use. So using a rendered sketch, design a base on which the lamp can be securely placed. Okay, so you see, even if you were to design something up here just to help yourself out, you could say like that you're gonna put it on you could decide that I'm going to try and put that on a rectangular base. You could decide to say it was timber, you know, but how would you put it onto that there then? So one way you could do it is you could, and just keep this out separate now, is you could just get 2 little brackets. So you'd have a bracket that slides in there, and you'd have another bracket over here. And just drawing them out there now with a hole drilled in them. And you could screw it down into the timber. Something like that. Like that would be pretty basic now, and it wouldn't look so good. So maybe then. But anyway, that is a nice simple possible answer. But then, you know, instead of that, you could go with an elliptical base. Or a circular base, or you could go with a triangle or a hexagon, or, you know, there's loads of different shapes that you could have gone with there. You know, that's some kind of a hexagonal base there. But just to kind of do something slightly different, I would suggest maybe sketching out here lightly like this, and we might just decide that we're going to go for something like in the shape of a shoe just to do something a bit different. And because they were looking for this to be rendered, I'll try doing it in a color. I'm not going to go with yellow because the body is actually yellow, so I might just go with red or something like that, or green or something. Yeah, you should always make sure that you got a couple of coloring pencils in with you in it. So I'll just put a little bit of now. The next thing, that's going to be our base. So we're going to be putting, so I'll just sketch lightly that you would have a leg coming down here, and here's one of these kind of triangular parts of that. There's the leg, so I'm kind of just copying that from over here. So I want my bracket, I would have one bracket going just here. And the other leg then is more forward a little bit. So that other leg is something like this. So, and then it goes off up here. So here now you can see why you don't want to sketch heavy in the beginning, because I just want to show those legs going up there. And behind that we're going to put another bracket on the ground. So the legs were yellow. So I might put the brackets in blue or something like this, even though, just to highlight them, even though really it would be better to put them in yellow because they just blend in, but because they're looking for how you do it, I'm going to leave them in blue. So So again, I'm not going to spend too much time here now on this, but you would go along and just shade in there then the top surface there of our shoe shape, and just make a few notes there onto it then. So we're just going to say that the base is in the shape of a shoe. So, and we're using just little brackets then. Just say 2 angle brackets. We'll just say mild steel. And that should do the job there. And it's no problem, it's a good idea to show your other ideas there, and just to say like that was an ellipse and this was a hexagon idea. So yeah, that will do there, and you can just say two angle brackets, so the base, and they're attached using screws. Then, identify suitable material for the base you designed and outline one reason for the selection of this material. Well, I would go with timber. I would go with a wood, like maybe teak or oak. And the reason is because it's not going to scratch table. And it's strong and heavy. And you can screw into it. Easily. Okay, because if you had metal there, it would be difficult enough to drill into that. So, yeah, that's what I would do with that anyhow. But again, there's no one right answer for that. Like, you know, you can put several. You could say, you know, acrylic or, you know, metal, even if you wanted, like, with a little bit of a pads underneath it or something. But, you know, it's more about justifying your answer there, really. Alrighty, then page 9. So, explain why copper is used in the manufacture of the electrical wires that are shown there. Okay, so copper, always used for wires. Why? Because it is a good conductor of electricity. Okay, now another one is it is malleable. So it doesn't break when it's bent. Okay, because could you imagine if the copper wires, if the wires in your house bent or broke easily when you bend them around the corner? It would be a disaster. So yeah, no, so copper is a very good conductor, doesn't rust and all that. Just add that as well, so it doesn't rust. And it's pretty cheap. Okay, way cheaper than silver and gold and other metals like that. So circle the correct classification for copper. So first means has iron. So obviously, well, maybe it's not obvious, but so non-ferrous, no iron. So that is the one. Because ferrous metal is iron and steel. Now 3, suggest another suitable use for copper. So it's used for hot water cylinders. So if you were ever to check in your hot tank, it's called a hot tank in your house. They're generally made from copper. So, and also the water pipes. Now part 4, insert the correct wire color for each of these. Okay, so the top middle one is green and yellow. So that's called the earth. Okay, so over here, oh yes, sorry, they're given here not. And the color here is brown for the live, and over here then is blue for the neutral. Then part F, So they're saying state 2 advantages associated with upcycling to produce bespoke or unique products like the table lamp shown. Now, upcycling is basically taking something that might be kind of waste and making something better out of it. So that's where the up comes from. There's kind of moving up the rankings in terms of it becomes a more valuable item. So one of the best examples for this is pallets. You'd see lots of people now making furniture out of pallets. So that's upcycling, because recycling is using it again as a pallet, but upcycling is making something more valuable from it. So what are the advantages? Well, one, it reduces waste. And two, it creates employment. And allows people to make money. So yeah, that's page 9. So page 10. So they're on about these e-trikes here. The Willow family e-trike is a hybrid electrical vehicle for transporting passengers and cargo in urban areas. Now, urban areas is towns and cities. It has a built-in rechargeable battery and solar panels on the roof. So these are solar panels up here, and during the day it gets charged up into the battery, and that provides power to the motor that assists the user while pedaling. Okay, so the driver pedals it as well. Now it can also take a passenger, so I presume it's just one person sits into that. So the following 4 terms are associated with the design and engineering of e-trikes. So solar power, cargo, hybrid vehicle, and carbon footprint. So complete the table by inserting the most suitable term next to the description. So a vehicle that uses 2 or more distinct types of power. Now look, if you are not sure of this, always go through them all and find one that you do know anyway. So heat radiation from the sun converted into electrical power. So that is solar anyway. Okay, so we know that one's out of the way. So let's reduce it here. And a measure of the amount of carbon dioxide released into the atmosphere by your activities over a particular period. So like that's your carbon footprint. So then cargo is the goods carried by a ship. So now we know that the hybrid vehicle is the vehicle that uses 2 or more distinct types of power. So always go through the list and put in the 1 or 2 that you know, or the easy ones if you're not sure, and then you could have a guess. And if you were stuck or not certain, just have a guess anyway. Always have a guess. Now, B, state 2 advantages of using the e-trike for travel in urban areas. Alright, advantages. Now again, you want to put in more than 2 really. But I would say one thing is it's quiet, because it's being pedalled and there's an electric motor in it as well, but both of them would be very silent, so it's quiet. And say at night, especially when people are sleeping. Now there's no I'm gonna say smoke or emissions. Now that's two. Now it's small, so it's easy to park. Easy to find parking, and it's safe in that, you know, much more so than motorbikes or cars or whatever. So it's safe, or I'll say, for people walking. So again there, I'm after giving 4, I look for 2, and that's page 10, which is question 3. Okay, so on to page 11 here. So it's just showing the light here in the front is an LED spotlight, and it's showing the brake disc here is a stainless steel brake disc. So explain LED. So LED is light emitting diode, which okay, so a diode only lets current flow in one direction. It's a semiconductor. And a diode only lets current flow one way. Now label the positive leg. Now the long leg is the plus. Okay, so if you, there's more of it there, it's plus, longer than the other one. So positive and negative. Now the current, you can put an arrow pointing up here and down here. You've got to put the current flowing through the long leg and down and through the short leg. It won't work in the other direction. As we said, it only allows current flow one way, so it has to go through the long leg and out through the short leg. Now, advantages of using LEDs over traditional light bulbs. Now, advantage 1 anyway is they use less electricity. They last longer than traditional light bulbs, and they give off less heat. Okay, so again there now, that's 3 advantages given there for that, and they're smaller as well. You'll often see them there in kitchens, LED light bulbs. They're often recessed, you know, they sit back up into the ceiling. Now, 2 reasons for the holes in the design of the brake disc shown above. Okay, so there's the brake disc. Now the one in the center is so it can be mounted on the shaft going through it. Okay, so the one in the center is for mounting it, and the other ones, there could be 2 reasons for them. There could be a decoration, or it could be to let air go through them so that they don't heat up, or to make the whole thing lighter. So there's lots of reasons. So we're going to write down some of those reasons down here. 2 reasons for the holes. Okay, so I'm going to say that they make the disc lighter and cheaper because there's less material. So the big hole is for mounting on the shaft, and the small holes let the air cool the disc, plus they look good. That would be a design reason. They just look stylish. I could say stylish or classy or something like that. So there is page 11. So page 12. Outline one advantage of using Allen screws in the assembly of the stainless steel brake discs. So, that's your hexagon, your six-sided Allen key screw there. Now, what are the advantages of them? Well, you can't use a screwdriver. Okay, so I'm going to say that you need an Allen key to loosen. So now they're good in that they don't slip easily when you have the right size. I'm going to say the correct size Allen key. Okay, so you need an Allen key to loosen, and so in other words, somebody with a screwdriver can't open it. Now, that said, if you wanted to steal it, I'm sure you could buy yourself a set of Allen keys. If you wanted to take off anything that's bolted on, but yeah, I think the main reason though really is that with Allen keys, when you've got Allen keys there, that you don't. It's much easier to put it on because the Allen key stays in the hole there. And I'm going to just say that there, that the Allen key stays in place better than a screwdriver. When putting on or off. Okay, so again, there's a couple of answers there. Now, explain why adhesives may be applied to an Allen screw when assembling a brake disc. Now, what he's putting in there is Loctite, and so it's to stop the screws from loosening. Due to vibration. Because anything that vibrates can cause a screw or a nut to loosen off over time. So that's why we use lock nuts that have the little nylon inserts, or you can put Loctite, which is like a kind of a soft enough glue, rubbery glue, that it'll come off easy enough. It's not like a super glue that goes hard and won't let you take it off. It's kind of a soft rubbery glue that if you do decide to take off the Allen key screw, you can just scrape it off with your fingernails or whatever, and so it's easy enough to take it off afterwards. So to stop the screws from loosening due to vibrations. So D, the e-trike is fitted with a pneumatic shock absorber. So explain pneumatic. So pneumatic means air powered or uses air. And And in this case there, now they only ask for pneumatic, so that's air powered. Example, rattle guns in tire centres. Used to be used in Formula 1 before, but I think they've gone to battery there now. Before you'd see the hoses for the Formula 1s, and basically in the absorber here, the shock absorber, there's air down here, so that if you hit a bump, the forks are driven down and it squishes the air, and so you don't get a shock up through the handlebars. It's all just absorbed by the air there. It's like having a syringe with the hole on the syringe blocked, so that it just compresses the pistons there. So air powered uses air, yeah. Then E, match the renewable energy source to the correct diagram for that source. Okay, so hydro energy is here. So again, looking at these here, wind energy is over there, so I think that is the easiest one. Now, anyone that watches The Simpsons will know that that's a nuclear power plant there, or something. It looks like a nuclear plant. So that says biomass energy, and we've also got geothermal. Now, geothermal is energy, heat being taken out of the ground. So in this case here, you can see the pipes going down there into the ground. So yeah, it's not nuclear actually, because nuclear isn't an option. So geothermal is water being circulated down under the ground to get the heat from under the ground. So that would be geothermal. Now it doesn't need to be particularly hot. You just need a couple of degrees of difference, like 4 or 5 degrees is all you need. It doesn't need to be like Iceland with hot springs. And biomass there then is basically using plants or timber or something like that, of stuff that is grown and chopped up. So that's like wood pulp being dug up there by or not dug up, but like being loaded by the excavators and stuff like that. So that would be the 4 of them there. That's page 12. Okay, page 13. So question 4. Engineering electronic control systems are frequently used at car parking facilities in towns and cities. So that's an automatic gate, and there's a mechanism there, and it's obviously a rack and pinion. If you know your mechanisms anyway, it's obvious. But A, number 1, identify 2 advantages of using an automated electric gate system. Well, automated means you don't have to get in and out of the car in rain, say in rain or snow, or particularly ice. Okay, for elderly people, if it was icy in that, to open it. So that's 1, and 2 then, it's safe, or safer anyway, in that you can control who comes in. In or out of your property. No, number 2, A part 2. The gate then shown above is made from steel. Suggests a suitable finish which may be applied to help prevent corrosion. Now there's a few correct answers here. Usually they're painted. but it could also be galvanized, which is dipping it in hot. It's called hot dipping as well, in hot zinc. And both of them are to prevent corrosion, as it says above here. And you could get smaller gates, could be plastic coated, but generally not, because if it gets damaged a bit, then it's hard to patch it up on that. That's why painting is generally the most common way. And unless it was stainless steel, now stainless steel would last alright, yeah, but painting is definitely the main one there. Next there, then circle the correct name for the mechanism A shown above. So the mechanism above there is rack and pinion. So obviously it's not a pulley and a belt in here, because you know what a belt looks like, and it's not a crank and slider either. So most people should know that in here, because it's pretty common. Then suggest one other suitable application for mechanism A. So where would you find a rack and pinion? Now the most common places in the engineering room to see these is on the pillar drill for raising the table. Now you'd also see it on the lathe for moving the carriage. So that would be two of the most common places that you would see them. Then, one other place you'd see there is car steerings as well. Also use or can use a rack and pinion. So then part 5 there, then explain why the surfaces of the roller wheel and the guide rail are heat treated. Now heat treated is basically heating up steel bright red or dark red and sticking it in water or ice or something like iced water or brine or salt water or whatever there. It's ways of, do you want to make it harder, or you can make it softer by heating it up bright red or dark red and letting it cool really slowly. It will make it soft. But if you heat it up bright red and cool it in water, cold water, it'll make it really hard. Now they said the surfaces are hardened. Now that's to stop them from wearing, because if the wheel is rolling over and back there on the guide rail, it would wear. If it was soft, it would get worn. So it is to prevent or to stop wear of the rollers and the rail. Okay, so that would be page 13. Now page 14, in the automated barrier system shown here uses a digital logic gate. So the barrier will only lift when the vehicle is detected, and now this "and" is important, and the keypad used. So it needs to detect a vehicle on the mat, so the weight of a car or something, and the keypad then as well. So the keypad is is it an input or an output or a process device? Now input device is the answer, because you're giving information in. So you're putting information in. Like an output device would be a speaker or the monitor screen or a printer or something. It's giving you data back out. But an input device is like a keyboard or a keypad or a mouse or something. It's giving the information in. Now, the following information is relevant to activate the automated barrier system. So if there's no vehicle it's 0, and if there's a vehicle, then a car, let's say a car, no car is a 0, a car there is a 1, and the wrong code is a 0 and the right code is a 1. So name the logic gate which is most suitable to activate the automated barrier system. That would be what's called an AND gate. Now the symbol for this, it's like a D, and there's 2 inputs and 1 output. So you need a signal from the car mat and a signal from the keypad, and then if both of them are a 1, then it will raise the barrier. So sorry guys, I had that off screen there, apologies. So I was saying there, the symbol for a logic gate there is like a D with 2 lines in here and 1 line out here. So as I just said before there, if you've got the car on the mat and the right code into the keypad, then it'll lift the barrier to let you in. So you need both. So the truth table here, now that's coming from up here. So look, what they're saying there, so input 1, draw the symbol and the logic gate and complete the truth table. So input 1, input 2 and output. So input 1 is the car. I'm going to try and label this here now. That's the car mat. I'm going to call it that. And number 2 is the keypad. And the output then is the barrier. So if there is, I'm going back to this then, if there's a car, it's a 1. So if there's a car, but this is if this is the wrong code, then nothing happens. And they're saying to complete the other options. So look, if a car pulls up and the keypad is put in correct, then the barrier opens. So that's everything correct. If there is no car and you put in you walk up or cycle up and put in the code, this one won't open because it needs the weight of a car there as well. You can't just walk up and put in your code and get this one to open. And finally, if there is no car on the mat and the wrong code as well, well then obviously the barrier won't open. So the only way it opens is to have a car on the mat and the correct code, then the barrier opens. So that's a truth table there. It's all basically the possible outcomes there. That's page 14 done. Okay, so page 15 here, it says using a rendered sketch, design a suitable bracket for the keypad shown, and the bracket you design must include a way to securely hold the keypad and a method to permanently attach the bracket to the floor. So it depends now on how good your sketching is, because you could draw this as a front view here. I'm going to say that's a base plate, and you could just have like box iron coming up here then, and that's just a piece of box iron there, and you could have a bracket going on up there for the keypad to fit into that there. And you could explain here then that you were using maybe roll bolts or something there going down into the ground. So something like that there. So it depends on whether you're like sketching or you're good at sketching or not. Okay, so this is like a front view there of so I'm gonna say box iron box. I'm gonna say steel. Make it stainless. So roll bolts into the ground, and you could say that's a stainless steel bracket for the keypad. And now they did say to explain how was it held on there, so you could just say that there was like a screw, or there could be like you could have put a lip, or you could have put a lip, I suppose, onto this and a lip onto this here, and you could explain there that there was a screw going up into this here, a fixing screw. Okay, so like that's a nice simple 2D answer there. Okay, if you don't particularly like sketching, now if you did like sketching there, then I'll have a quick go at this here now. So again there, might start up higher rather than down low. So if you were trying to sketch that in 3D, that might be the top of your box iron. Just put it down here a little bit. So you could then have a kind of a housing, I suppose I'll call it, for your keypad. So I'm going to make and I'm going to just show this now being a hollow box. And I'm going to put a base plate on this then. And just show a few holes on that there to bolt it down. Like that. And again there then, here's our keypad. I'll just sketch that keypad pretty quickly out here now. So I'll just stick a few buttons on it there, you get the idea. Just put an arrow there, that goes back in there. So again, that's a 3D sketch of it there, and a few little notes there. So a method to permanently attach the brackets to the floor. So again there, our method is roll bolts going down into the 4 holes there, and you could always show a hole here on the bottom of this, and just make sure that they see there that that hole for the fixing screw. To hold that on there. So yeah, that would be an okay answer for that there now. So part 2 there then. Identify 2 other applications where a keypad may be used. Well, they're used anywhere for getting into apartments. I'm going to say with no key, or for getting into swimming pools, or into banks and secure vaults where it's only certain people have the code for it and stuff like that. So again, throw a couple of answers down there just to be sure. And that is page 15 done. Okay, the automated barrier system contains circuits with various resistors. So state the value of the resistors shown. Okay, now the story here is with these, it is the first 2 are the numbers, and the third color is the amount of, it's to the power 10 to the power of whatever. So I'll take you through it here now and I'll explain this. So red is 2, so that's 2 multiplied by 10 to the power of 2. So that's 22 by 10 by 10 is 100. So that's 2200 ohms for that. And the next one here then, it's the same thing again. So the first 2 colors are the number. So brown is 1 and black is 0. Then automatically by 10 to the power of, and that's orange, which is 10 to the power of 3. Now 10 by 10 is 100, by 10 is 1,000. So that's 10 by 1,000 is equal to 10,000 ohms. And like, I might just do one more here just for an example again. So let's say it was red, orange, red. So it would be red, which is 2, orange, which is 3. Straight away then, multiplied by 10 to the power of 2. So 10 squared, 10 by 10 is 100 by 23 is equal to 2300 ohms. So that's how you use that resistor value table like that. Then part 2, state one advantage and one disadvantage of using robotic technology in industrial soldering. Well, the advantage of using robots, and there's lots, they can work 24 hours a day, 7 days a week, 365 days a year. Now I know they have to be serviced and all that. Okay, they are very fast to do repeat jobs and very neat and consistent. They never ring in sick, they never come in with a hangover, they're unbelievably productive. The disadvantages is they are taking your jobs. And helping the rich to get even richer. Inequality. So, yeah, robots are great for helping us all have like smartphones for a couple of €100 and flat screen TVs and all that stuff, but unfortunately they are going to be the cause of a lot of people being unemployed, I fear. So circle the correct alloy for solder, soft solder. Now look, iron and carbon, no, because that's steel. And okay, so copper and zinc is brass, so it's not that. And copper and tin is bronze. So lead and tin anyway is solder, but it's just good to go through them there just to remind people. So lead and tin is solder. Outline one advantage of using ribbon cable. Now ribbon cable there, my printer was a bit faded there, but the ribbon cable has all the different coloured wires stuck on together, and the advantage is it's very neat and tidy, as the wires can't get tangled around each other. And it's easy then to follow the colour coding. So you know, like if you put a green wire onto the switch, then that green wire is, you know, if you're connecting that onto the motor, to a resistor or whatever, like it's just very easy to follow the colouring on them. So guys, that is page 16. Okay, so guys, page 17. Yeah, and this is the last page as well, so this is the last question. So explain why a servo motor is suitable to control a barrier boom as shown. Now servo motors give you controlled turns, so like a lot of them kind of lift a barrier up through 90 degrees up and down again, like or maybe even 180 degrees. A lot of servo motors are set up that they don't even do a full rotation, so it's kind of suited for just controlled turns. Okay, so why servo motors are suitable? Okay, so they give controlled rotation. Okay, so they're often designed to turn 90 degrees or 180 degrees only. No, not always, like you can get them to turn the full thing, alright, but a lot of them are designed to just turn quarter or half a turn, and they're strong and quiet. And why a servo motor is suitable to control a barrier there, and a barrier only needs 90 degrees of rotation, so that's why they're suited to that. Now next, name the drive mechanism shown. Now that is a worm and worm wheel. Okay, so you can see the shaft there would be at 90 degrees to the shaft going through the worm wheel. So that's a worm and worm wheel or worm gear. Now, if the driver gear shown opposite has 14, now you need to label these. This is the driver. So that's connected to the motor, and that is the one that's turning, that's the one that's powering the other one. So this is the driven. So if the driver gear shown opposite has 14 teeth and the driven gear has 28 teeth, tick the correct gear ratio. So the correct gear ratio there is a half, or 1:2 there. So again, very important to understand that the driver gear is this one. That is the one that's powering the other one. So the driver is the one connected onto the motor, and that is forcing the driven one to turn. Now, the reason it's important to know this is because if a small gear with 14 teeth is turning a bigger gear with 28 teeth, one full turn here, 14 teeth is half 28. So a full turn of the red gear is only going to give you a half a turn of the big one. So the big one's going to be going slower then. The green one here is going to be going slower, half the speed. So they asked us here, calculate how fast the driven gear turns in revs per minute if the driver is turning at 40 revs per minute. Okay, so the driver is going at 40 revs per minute, while the driven one is going to be going at half that speed. So I know already that the answer is going to be 20 revs per minute, because half, it has twice as many teeth, but a half is 0.5. So you could go 40 multiplied by 0.5 is equal to 20 revs per minute. So that's the driver speed multiplied by the ratio. So yeah, now whereas if the big one was the driver, every time this turns, that would be going 28 teeth would turn the smaller one twice. So it would be making, if this was the driver, the red one would be going twice as fast, and your answer would be 80. It should be double 40. So it all depends on which is the driver and which is the driven. And a small gear will always turn a bigger gear slowly because of the number of teeth. So 14 teeth on this will only give you a half a turn on that. So this has to turn twice to turn this once. So it's going to go slower then because of that. So yep, that is all of those questions done. There, additional work here. So let's go back to our cover page. So guys, that is the 2023 one done. So I hope that helps some of you out there. Best of luck.